Hey guys, welcome back to another YouTube channel video with Big N, Little A, and Tiny D. So today we'll be solving the evaluation of the definite integral. This one right here, cosine 2x plus 5 from -2 to 9. So here are different answer options, and the correct one is A, 1/2 sine 223 minus 1/2 sine 1 plus C. So how to solve that problem? You first take the derivative of cosine and you get sine, and you take the integral, right, peanut, multiply it, and it's supposed to be flipped, because that's just what you have to do. And so you take the flip of that, and it's 1/2, and then you just keep that original equation right there, right? And now you're doing that from -2 to 9. So that means for every x value, you're plugging in one of these. So starting off with -2. Starting off with 9. 1/2 sine 2 times 9 plus 5 minus, because it's integrals, 1/2 sine 2 times -2 plus 5. Now we're just going to go ahead and simplify that a little further. 1/2 sine 18 plus 5 minus 1/2 sine -4 plus 5. And your final answer, 1/2 sine 23 minus 1/2 sine plus 1. And never forget, plus C. For the next problem, it reads, if f of x equals x squared y, what is the partial derivative of the function with respect to x? So here are answer options. Okay, here are the answer options, and the correct one is D, 2xy. So now we'll go over how to get that. First things first, take the derivative. So we see here, put it out front and subtract 1, that's 2x, times y. And that's it. All right, for question number 3, it reads, a function f of x has a tangent line at x equals -7 given by the equation y equals 4 times x plus 7 plus 8. What are the values of the function f of -7 and its derivative f prime of -7 at this point?
Hey, it's little a. I will be explaining this. Good job. But anyway, so the answer is B. F of 7 or -7 equals 8 and f prime of -7 equals 4. So first we need to find the slope, which is given to us in the equation right there. Yes, the 4. So slope is 4, meaning the derivative of -7 equals 4. Then we plug in -7 into the equation we were given, which gives us y equals 4, -7 plus 7 plus 8. Solving that, we get y equals 8, so f of -7 equals 8.
All right, guys, it's back to Big N, and this question is asking to find the antiderivative of the following function. F sine of 4x, that's it. So the correct answer is -5/4 b cosine of 4.
The correct answer is B.
All right. So first things first, this is obviously a u sub, right? Here's our u, and that's the sub. So take the derivative of the u sub, which is 4x, and you get 4 dx. And then you want to multiply, right? Cancel out front, multiply by 1/4. So that's 1/4 du is dx, meaning in the original equation, we're going to put a 1/4 in front. So here we are. Here's the 1/4 of 5 sine of u. Now, remember that u we talked about earlier? That's going to go right back there. So 1/4 times 5 is 5/4. Cosine is the integral of sine, which is negative, so that's where the negative comes from. 4x plus c. So the final answer is -5/4 cosine 4x plus c.
Next question is, if negative sine x squared y equals x, then dy over dx equals? And the correct answer is A, -2xy minus secant x squared y over x squared. To explain this, first we set it equal to x. Then we take the derivative of both sides, which gets us negative cosine x squared y times x squared y equals 1. Now we do the product rule, which gives us x squared y equals 2x times y plus x squared. Then we plug in to the equation we just found. So now we have negative cosine x squared y times 2xy plus x squared equals 1, and you divide that all by negative cosine x squared y. So then we we don't put it over, so we plug in, so we get negative cosine x squared y times 2xy plus x squared equals 1. Then we divide both sides by negative cosine x squared y. So this gives us 2xy plus x squared equals 1 over negative cosine x squared y. Negative 1 over cosine gives us negative secant. So then we have 2x squared plus x squared equals negative secant x squared y. We subtract 2xy from both sides. So now we have x squared equals negative secant x squared y minus 2xy, and divide both sides by x squared to get the dy over dx, which gives us negative secant x squared y minus 2xy over x squared, which is a.
Indefinite integral. Is this a use?
That was the non-calc part. This is the calc part.
Okay, for this next question, we're answering, find the indefinite integral of 1 over 5x, root 5x minus 2. So this is gonna be B, and we'll tell you why in this. All right, first things first, we're gonna re-simplify that. That is the same thing as 5x minus 2 to the negative 1/2, as we see right here. Now we're gonna integrate that, and it turns into that. 1/5 5x minus 2, 1/2, which is also has like a root over it, over the 1/2 power, or 1/2 plus c. So divide a fraction by a fraction, that turns into multiplication, and as we see there, that 1/2 is turning into a 2. 1/5 times 2, 5x minus 2 to the 1/2 power plus c, which is basically 2/5 5x minus 2, 1/2 plus c.
The next problem is evaluate the definite integral analytically. From 3 to 5, 2x squared plus 5x to the 4th. So first you can either plug into the calc or you integrate. X squared becomes 2x to the 3rd over 3. Or 2x squared becomes 2x third divided by 3, and 5x to the 4th becomes 5x to the 5th over 5. Then we plug in both 5 into the equation, and then you subtract it into the same equation you plugged 3 into.
If your answer is one of these, okay, can we go
Causing the correct answer to be C, 2,947.333.
Let's hope you're right.
Oh my god, it was so sad.
This is you.
Okay, this question says, if y equals x squared plus 5, which of the following expressions represents the derivative of y prime? The answer is D. So now, let's go over that. First things first, I'm going to take that derivative. So 2x, or x squared becomes 2x, and 5 just kind of disappears. And now we're going to plug in. So that's y prime equals 2x plus 0, meaning y prime is in fact 2x. So FRQ number 1. Let R be the region in the first quadrant bounded by the graph of f of x equals 1 over 5 root 5x minus 2. The vertical lines x equals 3 and x equals 5 and the x-axis. Part A, write but do not evaluate an integral expression that represents the area of the region R. Part B, find the area of the region R by evaluating the integral from part A. Part C, write but do not evaluate an integral expression that gives the volume of the solid generated when the region R is rotated about the y-axis. And finally, part D, Region R is the base of a solid. For this solid, each cross-section perpendicular to the x-axis is an isosceles triangle. Write, but do not evaluate, an integral expression that gives the volume of this solid.
So part A, area equals integral bounded by 5 and 3, 1 over square root 5x minus 2 dx. For part 2, you can plug in, and so you get u equals 5x minus 2, and then you take the derivative, so you get 5 dx, and because you need a 1, you bring the 5 out, so you get 1/5 du equals dx. X equals 3, which equals u equals 5 times 3 minus 2 equaling 13. And then when x equals 5, equals u equals 5 times 5 minus 2 equals 23. Then we get 1/5 and the integral bounded from 13 to 23, u negative 1/2 du.
It's literally right in front of you.
So then we get 1/5 2u 1/2, and then you plug in 23 and 13, so you get 2/5 times square root of 23 minus the square root of 13. For part C, radius equals x, height equals f of x, and the formula is v equals 2 pi integral AB, radius times height. So the volume would be 2 pi integral bounded from 5 to 3x, and then we multiply that by 1 over square root of 5x minus 2. Part D, A equals 1/2 base times height, or 1/2 leg times leg. The leg is 1 over square root 5x minus 2. So A of x equals 1/2, 1 times 1 over square root 5x minus 2, which also equals 1 over 2 times 5x minus 2. In the end, we get 1/2 integral bounded from 5 to 3, 1 over 5x minus 2 squared. Part A is 1 point, and you get it for correct integration and proper limits of integration.
Part B, you get 3 points. 1 point for identifying the correct antiderivative or u sub, 1 point for substituting the correct fundamental theorem bounds, and the final point is for the final answer.
Part C is 2 points. 1 point for the correct limits and 2 pi constant, and then 1 point for the correct integral.
Part D, you get 2 points total, 1 point for the correct area coefficient, and 1 point for the squaring the function correctly inside the proper boundaries.
So we're given the equation x squared plus 2xy minus y cubed equals 13. It's known on the point 2, -1 is on the curve. So to write an equation for the line tangent to the curve at the point 2, -1, I took the original equation and took the derivative of that. Don't forget that there is a product rule with the 2xy. So I got 2x plus 2xy prime plus 2y minus 3y squared y prime equals 0. Then I put the y prime on one side of the equation and then moved the 2x plus 2y to the other side of the equation. Then I divided the 2x minus 3y squared underneath the negative 2x minus 2y. To get my slope, I took the y prime equation and I plugged in the 2, -1, which left me with a slope of -2, and then I wrote it into the tangent equation, y plus 1 equals -2x minus 2. For part B, the equation for the line normal to the curve at the point 2, -1, I just took this equation and I flipped the slope. So we ended up with y plus 1 equals 1/2 x minus 2. For part C, to determine whether the curve is increasing or decreasing at point 2, -1, I just took the slope that we had already found. So that gave us our y prime equals -2. So the curve is decreasing at the point 2, -1 because y prime is less than 0. So for part D, to find the second derivative at the point 2, -1, I took the first derivative and I did the quotient rule, which left me with the second derivative equation of 6y squared minus 4xy prime minus 6y squared y prime minus 8xy y prime plus 4y over 2x minus 3y squared in parentheses squared. And then I plugged in my values, so 2, -1 from the original point, and then also the value we had found earlier, y prime equals -2, which left me with y prime equals -2. Then how I scored this was that if you found the y prime equation, I gave you 1 point for that. If you found the slope, 1 point, and then if you found the answer to the tangent line, 1 point. For part B, if you had found the correct answer, so just switching the sign and the number into 1/2, then you got a point for that. Then for part C, I gave you 1 point if you got the right value for y prime, and then if you got the right justification. Then for part D, I gave you 1 point if you did the quotient rule, and then if you plugged in y prime, if you remember to plug in y prime, then if you found the correct answer.